Hello, welcome back. In this segment, I will talk about a very important idea discovered by Shannon back in 1940s. His idea is to combine multiple crypto systems together to form a stronger crypto system. Suppose you have a crypto system, say S1, allowing you to do encryption and decryption, okay? And you have another crypto system, S2, which is also allowing you to do encryption and decryption. How do we combine these two crypto systems to form a new crypto system? Okay, he developed two methods. So I will talk about those two methods. His idea is that we pick a probability P. With probability P, we will apply crypto system S1, right? Of course, the other possibility is with the probability 1 minus P, we will apply the crypto system S2. Okay, so let me be more clear. This is not regular multiplication and addition. P is probability. So, okay, probability that you will use the crypto system S1. Okay, this is the probability. And 1 minus P is naturally the probability that you will use the crypto system S2. Okay. Oh, this plus means or, okay? So either you're going to use this crypto system S1 or you're going to use the crypto system S2. Okay, let's think about what is the benefit of doing this. How much security is improved because of combining these two systems. Let's assume the key space for the crypto system S1 is, say, K1, K2, Km. Okay, there are M possible keys you could use to apply your encryption on your message using the crypto system S1. Okay. Similarly, S2 may have other set of keys. Let's say K1 prime, K2 prime, Kn prime. These are a bunch of other keys that you would use to apply your crypto system S2. Okay. Now, if you think about it from an attacker's perspective, they don't really know whether meaning the sender, used the crypto system S1 or S2. Okay. Of course, the sender and receiver must agree on this probability P. Otherwise, the receiver cannot know which one to apply, either S1 or S2. So let's assume that agreement has already been taken place through some other mechanism. But for our purpose, let's assume that somebody is monitoring the traffic between Alice and Bob. Alice is the one who is encrypting the message using either S1 or S2 as the underlying crypto system. Somebody, Eve, who is monitoring this channel, now has a bigger task. Eve has to try not just M possible keys, she has to try M plus N possible keys, right? There are M plus N possible keys in this crypto system. Okay, so we can see that we have clearly amplified the security. Since S1 has only M keys, S2 alone has only N keys, but we bring them together, meaning we randomly select either S1 or S2, the crypto system S1 or S2. With probability P, we select S1. With probability 1 minus P, we select S2. Then we increase the key space for the eavesdropper, Eve, who is trying to break this communication channel and recover the key. Okay, if the goal is to recover the key, Eve has to try M plus N possible keys. Okay, that's one method. It's called the addition method, weighted addition. The weights are the probabilities that I'm talking about. P and 1 minus P are the weights. Okay, let's talk about the second method of combining two crypto systems. So we have two crypto systems, S1 and S2. How do we combine them together? Okay, so Shannon's second method of composition is basically called the product composition. What he has done is that he says, okay, first I apply S1, okay, on my message. S1 means the crypto system. I will call my encryption function on a message M using the algorithm S1. Essentially, that's how you should interpret this. Followed by, the star means followed by S2. Okay, so you can imagine that S1 is, say, for example, a substitution cipher, okay? And you apply substitution cipher on your input message, you get some gibberish. And then you take the gibberish and apply, say, for example, CIF cipher on your gibberish. Okay, so now you have basically performed two transformations on your input message. Okay, now what is the key space size of this new crypto system that you formed? Well, it's just multiplication, because for each key K1, you could say there are N possibilities. That means there are Mn possibilities. Okay, at most Mn possibilities. It's possible that I only say at most because sometimes this transformation has no effect. Two transformation is same as one transformation. Therefore, we could have no effect of applying 2 times. Okay, that's the reason I say there are at most mn possible keys when we combine 2 crypto systems in this fashion. We apply first encryption algorithm using the key k, whatever k that you picked, by using the algorithm S1 or a crypto system S1. We get some gibberish, and then we take the gibberish and apply S2, another system, and we produce the ciphertext. So the attacker has to now try at most mn possible number of keys. Instead of if we just use S1, he would only have to try m keys, or if you use S2, he could have tried only n keys. So now we amplified the system security by combining 2 crypto systems. This is a foundational idea developed back in 1940s. And this idea is actually used, as you will see later, when we go into the details of how DES and EES are designed, for example. They use this idea everywhere in modern cryptography. Okay, thank you very much. That's all.